Imagine artificial intelligence that not only writes texts, but also sees and understands our world and acts independently. An AI that not only functions as a chatbot, but also navigates factory floors as a robot, masters traffic as an autonomous vehicle, or solves complex tasks in the real world as a virtual assistant. This is no longer distant science fiction. It is the next major revolution in AI research, driven by so-called world models. And tech giants such as Google, Meta, and Nvidia are already investing billions to shape this future. So far, we are mainly familiar with AI in the form of language models such as ChatGPT. They were trained with huge amounts of text from the internet and are masters at predicting the next word in a sentence. But our world is not made up of words alone. It consists of physics, of objects that fall when you let go of them, of liquids that splash, and of people who move and interact. Physical reality is infinitely more complex than the digital world of text, and this is precisely where world models come in. So what is a world model? Or yet think of it as a kind of internal simulator, an intuitive understanding of physics that an AI has in its head. Instead of predicting the next word, a world model predicts the next state of the world. It learns how objects will behave and react. It can simulate what happens when a robotic arm reaches for an apple or a car drives around a curve. Essentially, AI learns the rules of our physical reality without us having to teach it every single physical law. She learns by observing, just like a human baby who learns that a ball rolls and a tower of blocks falls over when you push it. The key difference between language models lies in the input and the target. Language models process text to generate text. World models process visual data, videos, camera images, sensor data to predict future visual states. They create a condensed, latent representation of the world and learn to think and plan within this conception. This enables a machine to act not only reactively but also proactively. It can run through various courses of action in its internal simulation and select the one most likely to lead to success before making a single move in the real world. Why is this such a huge step? Because the physical economy is 1,000 times larger than the digital economy. The market for robots, for logistics, for manufacturing, for everything we can touch is enormous. An AI that can operate in this world has the potential to change literally everything. That is why experts are talking about physical AI as the next billion-dollar market. Those who achieve a breakthrough here will shape the future of industry, work, and our everyday lives. The big tech companies have long recognized this and are positioning themselves for this new race. Let's take a look at what they are already doing. Google DeepMind, for example, is working intensively on robotics. Your projects, such as Robotic Transformer or the integration of Gemini into robots, demonstrate precisely this approach. Robots no longer learn through laborious programming of each individual movement. Instead, they watch videos of people performing a task, such as clearing a table, and deduce the necessary sequence of actions from this. Their internal model of the world helps them understand the scene and plan their actions, even if the objects on the table are arranged slightly differently each time. Meta, the company behind Facebook and Instagram, is also conducting intensive research into world models. Their focus is often on predicting video sequences. Models such as VGEPA learn to predict parts of a video from the context. At first glance, this may just sound like a cool video editing feature, but the underlying technology is fundamental. An AI that understands how a scene evolves over time develops an implicit understanding of physics and the interaction of objects. In the long term, this technology could form the basis for advanced augmented reality glasses that provide us with contextual information about our real environment. And then there's Nvidia. As the leading manufacturer of AI chips, Nvidia is at the source of the computing power required for these complex models. But they go one step further. With their Omniverse platform, they have created a kind of digital twin universe. Here, companies can digitally recreate entire factories, warehouses, or even cities. In these photorealistic simulations, world models can be trained before they are used in the real world. A robot can fail thousands of times virtually without damaging expensive hardware. NVIDIA describes this approach as the basis for the next wave of AI. Embodied intelligence that is born in simulations and trained for reality. Even companies outside the traditional tech trio are involved. Niantic, the company behind Pokemon Go, is developing a so-called geospatial model. They create a 3D map of the world using the smartphone cameras of their millions of players. In the future, this model could be used not only for games, but also to help robots find their way around our cities. But the path to true, general embodied intelligence is rocky and far more difficult than the development of language AI. Data is a major problem. While the internet is full of text, there is only a limited amount of useful video data showing how to solve physical tasks. Who films themselves tightening a screw 1,000 times? Creating this training data is time-consuming and expensive. Another problem is the so-called sim-to-real gap. A simulation is always just an attempt to represent reality. The movement of a robot joint, the elasticity of an object, or unforeseen lighting conditions can be completely different in the real world than in the simulator. Transferring knowledge learned in simulation to reality is one of the biggest technical hurdles that researchers worldwide are working on. And security is also important. A language model that talks nonsense is annoying. A robot that makes an unforeseen movement due to a faulty world model can injure people or cause immense damage. The development of robust and reliable systems for the physical world requires a whole new level of security standards. Despite these challenges, we will soon see the first applications of world models in specific areas. In robotics, they will enable machines to master tasks in unstructured environments, such as sorting packages in logistics centers or assembling products with variable parts. Imagine a robot that can sort a box of mixed fruits and vegetables, a task that is extremely difficult for traditionally programmed robots, but solvable for an AI with a world model. In logistics, autonomous vehicles and delivery drones will benefit from this intuitive understanding of the world to navigate more safely and efficiently. Even in the gaming industry, world models could provide more realistic non-player characters that respond intelligently to the player's actions and create a more dynamic, believable game world. So when will physical AI really change our everyday lives? It will not be a sudden big bang, but a gradual evolution. Over the next 2 to 5 years, we will see its use in specialized industrial applications. In 5 to 10 years, we could see the first truly useful household robots that can do more than just vacuum. And in the distant future, these technologies could fundamentally redefine the way we work, how we get around, and how we interact with our environment. We are at the beginning of an incredibly exciting development. Artificial intelligence is currently learning to open its eyes and take its first steps in our world. It will be a journey full of challenges, but also with unimaginable potential. What do you think about this? Do you believe that robots and AI will soon be able to operate independently and safely in our real world? In which areas do you see the greatest opportunities, or perhaps also the greatest risks? Feel free to write your opinion and thoughts on this in the comments. Thank you for watching. If you enjoyed this video and want to learn more about the future of technology, then please leave a like and subscribe to the channel so you don't miss any new videos. See you next time.